Hello everybody, I made this video to help anyone calculate geometric mean and its confidence limits using Excel. Before you do this, you have to make sure that your data is either positively skewed or negatively skewed. As you can see here, the data I'm using for this demonstration is positively skewed, so I can confidently go ahead and calculate my geometric mean. The first step will be to log transform the data set. So here, I'm going to find the log to the base 10 of my values. Then, I'm going to calculate these parameters. So first will be to calculate the arithmetic mean, or the average. Next will be to calculate the standard deviation. Then the number of samples, or sample size. The confidence coefficient at 95% confidence interval is a constant value of 1.96. The margin of error is given by the formula 1.96 times the standard deviation divided by the square root of the number of samples. So I have 1.96 times the standard deviation divided by the square root of the number of samples. There we go. 95% upper limit is equal to the arithmetic mean plus the margin of error. 95% lower limit is the arithmetic mean minus the margin of error. So I have the arithmetic mean plus margin of error, and then arithmetic mean minus margin of error. Good. The third and final step is to calculate the geometric mean and the confidence limits. So this will be the antilog of the arithmetic mean and the confidence limits that we've already calculated. Antilog of the arithmetic mean antilog of the 95% upper limit, and then the antilog 95% lower limit. So this will be our final answer. Basically, geometric mean is the antilog of the mean of any log transformed data. I followed these simple steps to calculate the geometric mean of a project that I undertook, and I hope it helps you also. Thank you for watching.